let's go to our next topic. So for the next topic, we have the area bounded by curves in PCS, or in polar coordinate system. So as you can see, we have here an example of graph of any polar coordinate curve. As you can see, we have a graph like this, and we will just be getting the area of a sector. Okay, so remember that in this particular example, or in polar curves, r is in a function of theta. So the general formula is this one. So dA is equal to 1/2 r squared d theta, and getting the integral of both sides, you'll have here a is equal to 1/2 integral of alpha to beta r squared d theta. So formula for area bounded by polar curve. And then where the beta and alpha are in radian and measured counterclockwise from the x-axis. So let's move on to the first example. We have find the area of the region bounded by the cardioid r equal to 2, 1 minus sine theta. So I already drew the graph of a cardioid. So as you can see, all we need to do is to use the formula a equal to 1/2 integral of r squared d theta. But let's figure out first what are the limits. So what we will do here is we will just get half of the area and then multiply it by 2. Okay, so what happens here is we have to get this one. Okay, so this one up to this one. Okay, because that. So what will happen here, what is this angle? As you can see, of course, this will be your 0 angle. Okay, so this will be your 0. Okay, so this is your 0 degree, and then you have to measure the angle counterclockwise. So if counterclockwise, therefore this angle is this is also 270, right? So 270 degrees, this is 3 of pi over 2, and then for this one, this will be 90, therefore this is your pi over 2. So measuring it counterclockwise, so this will be the first one. Therefore this must be your upper limit of 3 pi over 2 and pi over 2. Okay, and then getting the integral, so integral a is equal to 1/2 integral of your r squared. Your r will be 2 times 1 minus sine theta d theta, and your limits will be pi over 2, 3 pi over 2. But I have to, okay, there's not enough space. Let me just rewrite this again. Okay. So rewriting that one, you'll have here a now will be equal to 1/2 integral of 2 times 1 minus sine theta squared d theta, and then the limits are pi over 2, 3 pi over. Okay, and then you have to multiply this by 2 due to symmetry. Okay, because we are getting only half of the area, so you have to multiply it by 2. So this one is due to symmetry. That's why we have here times 2. Okay, and then if you will just get that, get the integral of this one, or use your calculus, simply use your calculus, you will get here 6 pi square units, and this is your answer. Okay, so getting into the next problem. So we have the next problem, which is the find the area inside the lemniscate r squared equal to 2 cosine 2 theta, and outside the circle r equal to 1. So we are asked to find the area here, 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 and here. Okay. So that is inside the lemniscate and outside the circle. So there are 4 areas. So as you can see, there are again symmetrical with each other. So we'll be getting one of the areas of that and just multiply it by 4 to make the problem simpler. Okay. So first, as you can see, we have two curves here. Therefore, the area will be 1/2 the integral of r squared d theta. But since we have two polar curves there, therefore you have to subtract the area of them. Okay, so subtracting, writing first the larger area, which is the area of the lemniscate. Okay, so that will be our r2 squared minus r1 squared. Well, r1 will be the area of your circle, okay, d theta. Then we have to know what are the limits. So again, we'll be getting one of the areas, okay, only. Okay, so we have to get this area only. We have to get this area only. And then just multiply it by 4 because there are 4 parts. But we have to know what is this? What is this intersection, right? So we have an intersection, something like that. And then you will have here an intersection here. Okay? So that will be your first limit. Okay? And then of course we have a limit here, which is the 0 degree. 0 or in that 0 rad. Okay, so getting the intersection of that, all you have to do is just equate the two equations. So we have two equations, which are r squared is equal to 2 cosine 2 theta, and then r equal to 1, right? So if I will equate these two, so I can find the intersection. Therefore, using the first equation, you'll have here 1 squared equal to 2 cosine 2 theta. And then if you find the area, or not the area, the value of theta here, you'll get theta is equal to pi over 6. Therefore, that means that this intersection is pi over 6. Therefore, the limits of this one will be 0 to pi over 6. That's it. Then all you have to do is just substitute the values, okay, the equations, okay, and then integral of, so you have here 0 to pi over 6, so times r squared, right? So r squared is already here, so that's 2 cosine 2 theta minus 1 squared is still equal to 1. Okay, so this is already squared, but don't forget to multiply this by 4. Again, this is due to symmetry. So we are just computing one part of the area and just multiply it by 4. So this is due to symmetry. Okay, and you have here the theta. So if you will compute this one using your calculator, you will get 0.6849 square units. So that will be your answer.